Cambustion's DPG provides automated testing of diesel and gasoline particulate filters from low to heavy-duty flows and at a range of temperatures. The system is configured to test all aspects of filter performance in R&D or quality control applications more economically and with better repeatability than tests performed on an engine. The efficiency of a particulate filter can be strongly affected by the amount of soot loaded onto it. Penetration through a filter can change by a factor of 1,000 during normal operation. The DPG has the unique ability to measure the filtration efficiency of a filter both when it's empty and when it's loading up to full capacity, and even during regeneration. This video explains some of the tests performed by the DPG. We'll begin by measuring the empty filtration efficiency of a particulate filter. The DPG can perform this test in less than 3 minutes. The flow and temperatures within the filter are controlled. The burner produces a burst of particles with controlled duration and peak concentration. The DPG compares the integrated upstream and downstream particle concentrations to calculate the empty filtration efficiency. The empty filter has a relatively low filtration efficiency because the pores in the filter are much larger than the particles. In this example, the empty filtration efficiency is 90%. This section covers soot-loaded back pressure and particle filtration efficiency. Loading soot into a clean particulate filter at steady conditions allows the DPG to measure the soot load back pressure curve. Because of the initial low filtration efficiency, many particles penetrate deep into the filter wall, clogging the pores and causing a rapid rise in the rate by which the back pressure is increasing. By this point, a second effect is occurring. The particles begin to bridge over the pores in a soot cake as a layer of soot forms over the whole wall. This fine-grained soot cake provides a better filter. The DPG measurements show the filtration efficiency improving rapidly and the rate of increase in the back pressure beginning to reduce. Once the soot cake is established, it grows progressively thicker over time. Now, unless there is damage to the filter, the filtration efficiency is very high, often in excess of 99.9%, and the increase in back pressure is almost linear. Filtration efficiency and the back pressure of a filter are strongly affected by temperature, so a DPG includes electrical heaters to stabilize the temperature, and the test starts with a particle-free warm-up phase to ensure repeatable results. To measure the effect of soot load on filtration efficiency and back pressure, the soot rate is increased to a stable level which is representative of an engine, or the rate is accelerated, making the test time a lot shorter. Canned filters and after-treatment systems can both be mounted in the DPG. Also, the filter test housing can accommodate uncanned filters with more than 50 circular and non-circular profiles, from 4 to 13 inches diameter and of any length. This section covers filter regeneration. Periodic cleaning of the soot buildup inside a particulate filter is achieved by controlled regeneration of the filter. Oxidation of a large amount of soot is exothermic and causes high thermal gradients within the filter. The thermal stresses can crack the ceramic filter, permanently lowering its filtration performance. The DPG can simulate real-world regeneration conditions, including drop-to-idle events. More severe conditions can be produced. These will establish the soot load and temperature limits of a filter. Automated load and regeneration cycles can be used to rapidly test the durability of a filter. The DPG is available with up to 32 thermocouple channels, which allow the user to measure all thermal activity within a filter. This section covers ash loading. The accumulation of ash often determines the service life of a particle filter. Ash can enhance the filtration efficiency performance. The DPG can generate ash particles. The ash generation rate is controlled independently of soot generation, which allows the DPG to load ash with or without soot. The DPG can also load ash during regeneration conditions. The configurability of the ash loading rate and particle filter conditions allow the user to complete the test and understand the ash deposition characteristics for a given filter under controlled conditions. The last section of this video covers regeneration filtration efficiency. A DPG can be equipped with a high-power electrical heater that's capable of maintaining regeneration temperatures within the filter. Independently of this, the diesel burner can be operated in clean or soot-producing modes. This unique feature means the DPG can measure particle release from a loaded filter during regeneration, or measure stabilised filtration efficiency in continuous regeneration conditions at controlled flow and temperature conditions. The DPG is unequalled in its ability to perform a range of tests at the full-scale flow and temperature of a functioning diesel or gasoline engine in a fraction of the time. Cambustion DPG, for the automated testing of diesel and gasoline particulate filters. For further information, contact DPG support at cambustion.com.